Hello everyone and welcome back to Code Escuela. And so I've completed another coding challenge, which is build your own compression tool. And so the goal of this challenge was to build a tool or a command line tool that would allow you to compress text files. So basically it has 7 steps, and yeah, let's go through how I did this one. So let's jump into a flowchart that I've created. So this is a very simplified flowchart of two functions. So the first one is compress, which is to compress a text file, and then the other one is decompress, which is the opposite of compress, which is to unravel or undo the file that we had just compressed. So let's focus first on the compress part. So it has four simplified steps, which is first is to read the text file. Next is to encode, which is uh, broken down into 4 steps, and then after that you have the convert, which is to convert the file uh, into a byte form, and then save the file. So that's the actual saving of the file into its compressed format, right? And so the decompressed one is, it has almost the same set of steps. It's just composed of 4 major steps, and thus the opposite of what we did on the compressed one. So first is we read the compressed file, and then we convert, since it's in byte form, we convert it into its uh, original form, which is into characters, and then we do the decoding part. The decoding is again broken into 4 steps, and then after that we save it into its target file, which is basically the would end up as the original file itself. Okay, now let's jump back here to the compress step. So with the compress step, let's focus on the encode. So I'm not gonna go through what all of the code changes that I did, because you can uh, inspect it in uh, my Git repository. So I have all the commits that have been created along the way as I went through this challenge. And so yeah, I've added the steps in here so that you'll be able to track what part or what step and what I did with that step. So basically with step 1, I did at like a 2-step process. So the first one is just to count the characters so that we can create a frequency table from it. And then from there, you go into step 2, we build the binary tree. And for the binary tree, uh, it points you to this resource that shows you the Huffman algorithm for compressing stuff. And so I'm not gonna go through all of this again. And yeah, you can basically follow this one that would allow you compress characters into bits, and then from there on you can also do the reverse. So basically uses a binary tree that would allow you to generate all of the equivalent binary codes or bits for each of the characters that you have in your file. All right, so that's the gist of this. So you have also the decoding and stuff like that. And so yeah, after that you have step 4. I missed to add a description, but step 4 is where you have the creating the header. So the header section or the header part of the compressed file is where you put all your necessary information so that you can decompress or uh, unravel your compressed file later on. So with this one, I opted to just write out the frequency table instead of writing out the tree. One way you can do writing out the tree is to write it as a JSON structure, all right, or in JSON format. So that would be easier. But then again, I think it's possible that you can just use the built-in JSON system.json, text.json library to do that, where you can serialize your tree structure or your binary tree into JSON format, and then you can write it out on your compressed file. And then the rest would be a combination of step 5 and 6. So yeah, it's a bit messy on this part since I had to do the encoding and decoding. All of this I've done through TDD, or test driven approach. So before I've started even step 1, so with step 1, I tried to create a frequency table, and then each of the step would have its equivalent test. So if we do the frequency table here, this is the test. So this is very like cowboy style, wherein uh, the with the variables that I'm testing is just a hard coded value here, so that it's easier or faster for me to debug later on while I was doing this challenge. And so yeah, let's jump right back into our flow chart. So let's focus on the encode step here. So with the encode, it has 4 steps or sub steps. First is you build the frequency table, which is part of step 1. Next would be to build the binary tree. So building the binary tree is on step 2, all right? So your biggest tool here or reference would be this Huffman coding resource that points you to this one. So basically, it talks about building a binary tree. First, you'll have to have the frequency table, and then from there, you build your tree based on the frequencies that you get initially. And then after that, once you build up your binary tree, so the binary tree here would mean that in this case, for example, it would form like this. So each of the characters would have its own leaf node, all right? And then what you end up there is, after that, you build your uh, binary code assignments. So if you shortcut this one, you see that you have this 0 and 1 on each of this branch. So that's how you build up your uh, codes. Okay. So after you've created your binary codes assignment for each of your characters, then you generate a header. So in this way, you'll have information on how to decompress your compressed file. And then after that, you convert everything into chunks of bytes, or a group of 8 bits. All right. And then after that, after you've done that, then you save physically on the file, right? So let's look at the code for that one. So this would be the encode, right? So with the encode part, you see here, I've turned them into specific methods. So these methods also has their equivalent unit test. So first up is build the frequency table. So you have this part here. Then after that, we build the binary tree using the Huffman coding. And then after that, you assign the codes. And then from there, you generate the header. And then you combine them together as part of the compressed method. So if we go to this is the encode part, right? After you've completed all of these sub steps, then check the compress method. That's where the encode part goes. Encode, it's right here, almost at the beginning, all right? And then this is the the conversion from your bits into bytes, or group of 8 bits. Since, yeah, I'm a bit stubborn here, you can always separate this out into a separate method, on its own method, right? So after you've done the conversion into bits, and so there's a bit of special case here. since I've compacted them into 8-bit chunks, the last part would be a tricky one because uh, what you end up is after you've encoded your uh, contents or your strings, there would be a case wherein the last chunk of bits wouldn't equal like a complete 8 bits. All right, it could either be, it could vary. So in that case, uh, if you don't uh, complete enough of the padding of zeros, then you might miss out on correctly interpreting the final byte. All right, so the last bit chunks could mean that it could be this kind of bits, or a complete 0 bits. But if you convert this into a byte, then you'd end up with just 0. So what I did here is the last set of bits is uh, convert it into number of 2 bytes. So the first byte would be the actual value, and then the second byte would be the number of zeros that would be padded in case there is a 0 at the start of that bit sequence. Okay, so we add that to our byte list, and then after we've completed that, then we combine everything including the header. So the header is also converted into bytes, and then in this case, I've concatenated the header and then the uh, what you call the prefix, or the decoded, or the, I mean the encoded bit strings, and then finally write it out in the file. So that's where the save step is. Okay, and then yeah, after that we do the decompression, or do the opposite of compress, or unraveling the stuff that we just compressed. Okay, so what happens here now is that we now read the file. Since it's written in bytes, then we read them as bytes, a stream of bytes, or an array of bytes. Okay, let's head to our decompress method here. And so here you can see that we've read, or we try reading our compressed file as bytes, or byte array. And then first off is that we need to uh, take a hold of our header information so that we know how to decode everything. So since in the compressed step we have added the header as the first part, then it's quite easy to just decode the header section. Since they are already in byte form, then we can just do this convert to char for each, then and then we check if we have reached the header end text. So this would be an indicator that that's the last section of the entire header section. Okay, and then from there on, we just decode everything. So all of the bytes is converted into its bit string form. All right, so back to the ones and zeros. And then what we did here is that we pad it into 8 in a length of 8-bit width. All right, since some of the values, if the values are lower than 8 bits, then it would basically just uh, it would have an empty space that wouldn't complete the 8 width requirement. So for that case, we need to pad it with zeros. Okay, so you won't know if how many zeros would come first. So this pad left would allow us to do that. Okay, and then after that, it's we do the decoding. Okay, now we do the actual unraveling of the bits, the one that we did initially in the compress, and then we follow that route using this binary tree that we did on, like we did on compress. We do that here, so we recreate everything. So if we inspect the decode, you can see that after uh, getting the header information here, and then getting the frequency table. So that's the step here. So we recreate the frequency table from the header information. After that, we do and build the binary tree, and then we assign the codes that we have generated from the binary tree, and then we do the decompressing of stuff, or contents in this case. So that's where we decode to the characters or the contents. So you follow this one again. If you have your bits of ones and zeros, if it's 0, then that the final leaf node would be E. Then yeah, replace that set of bits as that character, and so on. All right. And then after that, after we've completed the decoding, then we just write everything out as a text, since everything, or all of the compressed contents from the origin, I mean the source file, is just text. Okay, you can always run the test here. So there's only a few of those tests. There are currently 8. Okay, each of those steps has their own equivalent unit test. So running this one, you'd end up with uh, the actual file. So let's open and check. I've run this earlier so that we don't spend time running it here, but it shouldn't take long. If you run the unit test, yeah, you'd only take at most 3 seconds. Okay, where is the, why not we just rerun this one? Okay, it's debug. Okay, I've opened. That's this supposed to be the unit test 1 project. Okay, let's open the bin debug.net 8. All right. Okay, so now we have this. This is the generated compressed file of the test file. So the test file that this challenge is referring to is a copy of the Les Miserables. So forgot where I've got that. Here, right? So this file, I already have it here as part of here this test the text. So if we check the contents of that, it's this one. So it's quite a lot. It's around 3.21 MB. All right. So 3,291 kilobytes. And then with the compressing that we've done, it's now 1,876 KB or 1.83 MB, like almost half compression of like almost 50%. I'm not quite sure exactly with the numbers, but yeah, around that uh, number. Okay, and so the decompressed one is this one. When we do the decompression, so it's exactly the same size. So decompress that text here is 3291 KB. The test would be 329 KB. Now to check if uh, they're exactly the same, I have here opened. Let's see. Yes, I think it's this one already opened. Okay, yeah. So the one on the left is the actual test file, and then the one on the right is a decompressed one. So they're basically uh, just the same file after we are coming from the compressed one. All right. Oops. So I've switched my desktop. Okay, let's go back. So that's how, yeah, this challenge. I have the stuff that I've done with this challenge. So again, it took me a while to actually finish this one. Uh, the most longest part that I've done is the actual decompression of stuff. So I have to struggle with, like, especially the last part wherein we need to turn it into bytes. That's the most tricky one for me. And then yeah, so yeah, you can just check check out the code. It's already on the repository, and with the flowchart, I will also add this one, so you have some reference later on. So yeah, I think that's pretty much what I've done for this one. I don't know if this would be uh, the correct way of doing this, but yeah, I've hopefully satisfied the steps, each of the steps. And yeah, by the way, this is done in C sharp. My environment is Visual Studio 2022, and yeah, that's it. And uh, I, because I'm stubborn, I forgot that it is supposed to be a command line tool, but somehow I've done it as TDD, and so everything is uh, done as a test. Okay, I've done all the code via test driven approach. So there's no equivalent command line or console application that I've done for this one. It's supposed to be a command line tool, but yeah, it would be easy to just use uh, this compression tool object or class that we did. So basically, if you want to actually do this as a console app, then you might want to receive a target file, and then I mean a source file, and then a target file of that would allow you to choose a your own name for the compressed file. Okay, and then the decompress part, I think I've already, yeah, so it's just need source and then a target. Okay, so yeah, maybe that's the way you can improve on this one. And so yeah, I think that's pretty much it. If you have some idea of anything, any thoughts, any comments about this one, whether uh, I could do much better for this one, let me know in the comments, and yeah, we'll see if we can further improve this one, if yeah I have time and we have time to discuss about this one. But let me know anything if you have any thoughts about this one. So yeah, uh, I guess I see you again in the next coding challenge, which would be build your own cut tool. So I'm hoping I won't spend too much time on doing this one, because yeah, I've already done 3 challenges, and yeah, I'm looking forward to doing the rest of all of these challenges. And so yeah, uh, I guess that's all for this one, and don't forget to like and subscribe to this channel, and yeah, see you again in our next video. And thank you everyone, and enjoy the rest of the day.